Okay, let's check our levels. It looks like we have good audio. And ladies and gentlemen, I'm going to go over the acceleration of a particle. Now, really, the details of the video is going to be regarding the time t for which you may say acceleration is zero or acceleration is positive, acceleration is negative. Now, remember one important aspect about acceleration. Since force equals mass times acceleration, F equals ma, a force is a push or a pull. So when they ask you this kind of question and they say, determine the acceleration A of t, where it is zero, no acceleration, no push or pull, and at time t for which the particle is being pulled in the positive direction. So the particle is being pulled in the positive direction, right or up, and the time t where the particle is being pulled in the negative direction, which is down or left. Depends on the horizontal movement, or if you're saying vertical movement, horizontal will be right, left. Vertical is up and down. And so essentially we want to know, at what time t are you going to be having no pull or having, we should say, pull to the right, pull to the left. Okay, that's what they want us to think about. So in this video, we started with the position function, and time is always greater than or equal to zero because we don't have any concept of negative time, at least for calculus 1. And we actually computed in the last video on velocity for this particular position function that v of t is 3t squared minus 12t plus 9. Now, the essence of this video is to perform sign analysis on the second derivative of the position function, or sign analysis on the acceleration function. So I want to put that down there. And away we go. Sign analysis on acceleration. It's going to answer everything we need. So, okay. Acceleration is derivative of the velocity function. By properties of derivatives, here's what we got. Okay. T squared, 2t. Derivative of t is 1, and derivative of a constant is 0. And I think that's 12 times 1. Okay. 6t minus 12. So we found the acceleration function here. And remember, we're going to perform sign analysis on the acceleration to get the time t for which acceleration is 0, positive or negative. So you're going to set a of t equal to 0 now. So that means 6t minus 12 is 0, or we should say 6t equals 12. T equals 2 seconds. So, okay, we know when acceleration is 0. That happens at 2 seconds. That means there is no push or pull. Okay, so I just want to kind of remark about that so you guys are aware. There's no push or pull. at t equals 2 seconds. Okay. Now, in the form of sign analysis here, this is an important piece of information. We know at 2 seconds, if I do it this way, let's put 0, that's important. We know at 2 seconds, acceleration is 0 here. So, region 1 to the left, region 2 to the right. We don't care about any time less than 0 because acceleration, or I should say the position function, like velocity and acceleration, apply only to t being greater than or equal to 0. All right, now we need test points. So since 1's available, I'm going to use 1. And I'll say 4 is available. I'll use 4. It doesn't have to be 3. Any number clearly in the interval. It can't be where it equals 0. Okay, we're going to test the acceleration. And we're testing the sign. So we're testing 6t minus 12. We really don't care about the value in sign analysis, just the sign of positive or negative. But all right, let's test 1. So a of 1, 6 times 1 minus 12. A of 1 is negative 6. So it's negative. Plug in t is 4 now. And we can see a of 4, 6 times 4 minus 12. 24 minus 12, which is 12. So a of 4 is 12. And it's positive. Now, let's be careful. We're going to put the units centimeters per second squared. Centimeters per second squared, okay? So at 4 seconds, acceleration is 12 centimeters per second squared. So that's kind of interesting, but under sign analysis, we want to point out that this is 12 here. So, ladies and gentlemen, that's a very big deal because now we have all the information we need to answer the question. So we're going to answer these questions here. So we're going to identify, first of all, what I would say intervals, because most of our answers are going to be in the form of an interval. Acceleration is 0. We already concluded, and we're going to write that down here. Your acceleration equals 0 when t equals 2 seconds, and particle has no push or pull. Okay. Now look at this first interval here. That's for time values between 0 and 2. So between 0 and 2, acceleration is negative. So we're going to have to plug in here, or we're going to have to describe that interval as between 0 and 2, including 0. It has negative acceleration. So acceleration is negative. That means a particle is push or pull to the left. I'll just say you have a left pull. Okay? So I want you guys to notice this extremely important detail because that's really what they're asking for. They're asking for when is the particle, for what time is a particle being pushed to the left or pulled to the left, push or pull to the right. So I'm going to just answer the questions left to right. T greater than 2 seconds, you're going to have a right pull. And that's what they're interested in knowing here. So we can actually see that in this picture here, the sign analysis picture. This is essentially what they want you to do. Sign analysis on the second derivative and interpret the results. Okay. So ladies and gentlemen, there you go. Here's your answers. This is for question number 1 now. All right. We did question 2 in class, and in fact, I'm only going to do the odds today here on this. So question 2 is done in class, and I'm going to do the odds for us. 1, 3, 5, and I'll send this to you all. So, okay, yet again, we're going to repeat the process. They give us a position function for t being greater than or equal to 0, and they gave us the velocity function because we determined that in a prior video. So, your acceleration function is the derivative of the velocity function. Your velocity function is 3t squared minus 12. And so by properties of derivatives, we can pull this out. Derivative of t squared is 2t, and the derivative of 12 is 0. So I end up with 3 times 2t minus 0, or just 6t. Okay. So here is our acceleration function. Alrighty. So remember, we're going to do sign analysis on this. So we have to set at equal to 0. And when you do, we get 6t is 0, and dividing both sides by 6, we'll get t equals 0 seconds. So here's your time where acceleration is 0. And there's no push or pull then. So I want you guys to take a look. There's no push or pull. Whatever you want to describe that. Now, so this is an interesting sign analysis question. The reason it's interesting is because at 0 again, we want to test the signs of region 1 and region 2. However, you get to throw out region 1 because your time is strictly positive. You need a test point. You need a test point here. You want to test the sign of region 2. And you do that by plugging in your test point value. So a of 1 is 6 times 1, or we say a of 1 is simply 6 centimeters per second squared. So region 2, which is the only region to test, is positive. So I'm going to label that here. And I want you guys to take a look at this and understand an important detail. In this picture, there's only 2 situations. The particle has no push or pull at 0. No push or pull at 0. And the particle is only being pulled in the positive direction. It's never being pulled in the negative direction because there's no interval in which you have negative acceleration. It is strictly positive acceleration or 0. So here's our conclusion. Acceleration equals 0 when t equals 0 seconds. No push or pull. Acceleration is positive for t being greater than 0 seconds. So you have a right push or pull. There is no negative acceleration. So, I mean, you could just leave your conclusion this way and that should be fine. But ladies and gentlemen, not a big deal. You don't have to write that phrase down, that there is no push or pull to the left. So I'm going to write it anyway. I'm going to say there is no push or pull to the left because the acceleration is not less than 0 for any t. So that's the picture you guys are looking at. So there you go, ladies and gentlemen. Okay. Like I said, I'm only going to do the odds. And let's see what happens in this question here. So again, we have a position function for t being greater than or equal to 0, where we were given a velocity function. We need acceleration. Acceleration is the derivative of velocity. So we're going to say 15t squared minus 8t. Okay. Properties of derivatives, if you want to see every gory detail. Let's get rid of that. Two t minus 1. So acceleration becomes 15 times 2t minus 8 times 1. Or we say acceleration is 30t minus 8. So here's our acceleration function. So ladies and gentlemen, we're going to do sign analysis on this again. So set your acceleration equal to 0. Find where the particle has 0 acceleration. So we say 30t minus 8 is 0. We can add 8 to both sides and get 30t equals 8. We can divide both sides by 30. T is 8 over 30. Now I'm going to simplify this. 4 over 15. Let's double check. 8 divided by 2 is 4. 30 divided by 2 is 15. We can't simplify any further. So acceleration is 0, ladies and gentlemen, for this value of t, 4 over 15 seconds. Okay, that's a bit different than the last, I should say, problem. And maybe I'll just try to see if I can put this on the crease. I don't know if that bothers you guys, but it bothers me a little bit, so. Okay. So if I put 0 in the middle, I'm going to put 4 over 15 here because we're going to do sign analysis on the acceleration function. And in this time, we do have 2 regions to check. So I'm going to put 1 over 15, or I can put what's in the middle, 2 over 15, as a test point for region 1. Remember, we don't care about negative t values because time is greater than or equal to 0. So we need to check again the signs. Sign analysis. 2 over 15 and 1. We're going to check the acceleration function here, okay? So we have to, I'm going to copy that now. We want to check the sign for acceleration. So we're going to plug in now the 2 over 15 here. So 2 over 15 becomes, and it's 30t minus 8. Looks like we didn't get everything here. So hopefully we have it all. 30, 2 over 15 minus 8 becomes 2 times 2 minus 8, because 30 divided by 15 is 2. And that's 4 minus 8. So our acceleration is negative 4. And we'll say centimeters per second squared. So what we know is there's going to be a left pull for this particular region. So this is negative acceleration here. And this is region 1 now, okay? Let's test the next test point, which is positive 1. So we're going to have to test positive 1 now. 1, 1. So A of 1 becomes 30 times 1 minus 8, which is 30 minus 8. That's positive 22 centimeters per second squared. This is our acceleration. Positive. Okay. So yet again, you have all the information you need right in here. That you're going to do sign analysis on the second derivative, or I should say sign analysis on the acceleration function. Let's draw our conclusions and say, okay, the acceleration is 0 when t equals 4 over 15 seconds. And at this time, there is no push or pull, and I'll just say push. Now, let's take a look and just read again left to right. So region 1's negative for acceleration. So I'm going to say here, acceleration is negative for the values of t between 0 and 4 over 15. So here we go. And in that case, you have a left push or pull. Acceleration is strictly positive in the positive region. So that's from 4 over 15 to infinity. And so we can say t greater than 4 over 15 seconds. And then we have a right push or pull. I'm out of space there. So let's look at the colors. Maybe this helps you. Okay, so there we go. This helps. Fine. And so, ladies and gentlemen, take a look. This is how you can see your answers. Now, in interval notation, just to kind of share with you guys some of that, because I don't think I've, in this video, I know in the lecture I've described it, but in this video, I just went straight to describing in terms of t here, partly set notation. Okay, partly. There's no interval here, but I'm just going to remark here if I can, and I can try to move things here. Okay, in terms of interval notation, 0 is included, but 4 over 15 is not. So we have a bracket around 0 and a parentheses around 4 over 15. This is 4 over 15 to positive infinity. So there's a parentheses around 4 over 15 because you do not include it. It's not, I should say, at 4 over 15, that equals 0. It's not greater than 0. And we go up to infinity, and we never include infinity. So this is some of the interval notation that I did not remark with, at least in these videos, but I have remarked about in class. So, ladies and gentlemen, take a look here. I think the essence of this is to understand a few things, that they're asking for a particular time now when you have acceleration being positive, negative, or 0, and that is going to be sign analysis on the acceleration function. And all your answers are based on that. And a negative acceleration means the particle is being pulled to the left. Positive acceleration means a particle is being pulled to the right. Zero acceleration, remember, 0 is neutral. That means there is no push or pull in the particle for those times. And that's the essence of this. I'll send it to you. I hope you guys enjoy this. Take care. Stay safe.